Good morning, guys. Today our focus is going to be on Newton's third law of motion. We've already talked about his first law, which says that an object in motion will stay in motion and an object at rest will stay at rest until acted on by an unbalanced force. We've also talked about his second law, which says that the force of an object is equal to the object's mass times its acceleration. We've also calculated either the force, mass, or acceleration of an object dependent on the variables given to us in the problem. And then today our focus again is going to be on his third law. And his third law says that for every action, there's an equal and opposite reaction. And so we're going to be talking about force pairs. And for whatever we do to something, that something does the same back to us. While the result may not be the same, the forces acting on an object are always equal and always opposite. So we're going to be talking about action-reaction. Newton's first two laws of motion explain how the motion of a single object will change. But his third law describes something else that happens when one object exerts a force on another object. So as we move forward and we talk about exerting a force, I want you to just imagine you pushing a box. That's what we're talking about, okay? According to Newton's third law of motion, forces always act in equal and opposite pairs. So the forces exerted by two objects on each other are often called action-reaction force pairs. So if you look at the image at the top with the balloon, the air is rushing down, which forces the balloon up. And so the forces are both equal and opposite in direction. Either force can be considered the action force or the reaction force. It doesn't matter. And because they're equal and opposite, we can choose either one to be the action or the reaction force. Now, action and reaction forces pairs do not cancel each other out because they act on different objects, and that's really important to understand. Okay? So his third law states that for every action, there's an equal and opposite reaction. So if you look down at the bottom, we have this man pushing on a wall. And so let's just say, to make the numbers easy, that the man is pushing on the wall with 10 newtons of force. Now, that amount of force is probably not enough to move the wall, because most walls are built to be able to withstand forces that small. But the wall is also pushing back on the man with the same force. Now, again, it's hard to understand because when we say something pushes on something, we think that it's an animate object, something that's alive. But it doesn't have to be alive. Okay, so for example, sitting in your chair, you are pushing down on the chair and the chair is pushing up on you with the same exact force, very similar to how gravity and the normal force work. Now, the reason that the wall doesn't move is because the man is not using enough force to overcome the wall's mass or inertia. And the reason that the man doesn't move is because the wall is not exerting enough force on the man to overcome his inertia. So in this situation, it would be a stalemate where neither object would move. So when you push on a wall and the wall pushes back on you with a force that is equal in strength to the force that you exerted on the wall. We constantly use action-reaction force pairs as we move about. When you jump, you push down on the ground, and then the ground pushes up on you. It is this upward force that pushes you into the air. Okay? So all of our energy when we jump is directed downward towards the earth. But our reaction to that force is upward, which means that we are pushing on the earth, but the earth is pushing back up on us. So when rocket fuel is ignited, a hot gas is produced. And as the gas molecules collide, because when hot gas molecules get hotter, they start to move faster. And so when they collide with the inside of the engine walls, the walls then exert a force that pushes them out the bottom. Okay, and so as that gas pushes down, because of Newton's third law, then the reaction force is to push the rocket up. So if we're pushing the gas down, the gas is pushing back up on the rocket in the upward direction. And this is how rockets get into space. So this downward push is called the action force, and the reaction force is the upward push on the rocket engine by the gas molecules. And there's some videos embedded in here for you to watch if you need a little bit more explanation. And this is the thrust that propels the rocket upward. So last night, SpaceX and NASA launched Dragon Crew 1 up into space. They are currently orbiting in space, looking to rendezvous and dock with the International Space Station. And so the term rocket science really is about understanding in its totality Newton's third law. So again, as we review explaining Newton's third law of motion, it states that forces always act in equal and opposite pairs, and for every action there is an equal and opposite reaction. And if they are equal and opposite, why don't action-reaction pairs cancel? And the reason for that is because they're acting on different objects, and those different objects have different masses. Okay, so if we were to have a ping pong ball on the table and we flick it with our finger, the amount of force acting on the ping pong ball would cause the ping pong ball to accelerate away from us extremely quickly. Now, the ping pong ball exerted the same force on us, but because we are so much more massive than the ping pong ball, we do not accelerate because the ping pong ball didn't exert enough of a force to accelerate our mass. So there is a connection between Newton's third law, second law, and first law. So the ping pong ball has inertia. It doesn't want to change what it's doing. The only way that it's going to change what it's doing is to have a force applied to it. That's Newton's first law. Now, the force applied to it times the mass of the ping pong ball, or divided by the mass of the ping pong ball, would give us the acceleration that the ping pong ball would move. And then, of course, Newton's third law says that for every action, there's an equal and opposite reaction. So if we apply a force to the ping pong ball will apply a force back on us that is equal and in the opposite direction of the force. Now, again, we may not accelerate like the ping pong ball, but the forces are equal and opposite. All right, guys, so hopefully that's Newton's third law in a nutshell. Pretty simple. On a conceptual level, we'll talk a little bit more about it as we move through the week. If y'all have any other questions, make sure you reach out to me and let me know.